Hi, my name's Don. Welcome back to Project Urtle. In this episode we're going to be covering the electrical system for the camper. Well, this rat's nest is the backside of my electrical panel inside the cabin. This is where all the controls will sit. The guts of the system will sit in the electrical cabinet. But this shows a row of switches, a level sensor, a push button and a couple of displays for the electrical system. Okay, this is probably fairly self-explanatory. The panel has a panel monitor here which monitors state of charge of the battery, which is 300 amp hours of lithium iron phosphate batteries. This panel is a remote control for the inverter, which is a 3000 watt continuous or 6000 watt momentary load inverter, which will power the hot water system and the induction cooktop. This is a water level gauge for the water tank. External lights on the passenger side, internal lights above, external lights on the other three sides of the unit, and water pump switch. And the last one is a momentary push button which will kickstart a timer which will run the hot water system heater for a set period of time. Of course, if the heater gets up to temperature in less than that, well, it'll shut itself off. But I wanted to make sure that the hot water system, which is a fairly high current drain, only runs for a limited amount of time. So I want to be able to heat the hot water system once, have it power off, and not come back on again to try to keep that hot water thermocycling to keep it hot. I wanted to heat the water, use the water, and not turn back on until I'm ready to use hot water again. And so that's what that switch is. It'll operate a relay and a timer in the main electrical cabinet. Okay, this little hatch in the side, passenger side near the front boot, is the electrical cabinet. And I've started to fit that out. All the wires from everywhere else in the cabin have come back to this point after mounting the main control panel inside, and I've just mounted the DC to AC inverter, which has got a fair old job to do. A lot of high current work. The other project completed today was to fit the batteries into the battery box. The battery box is here under the dinette seat on the passenger side. I'll just open that up and have a look inside. Here we have three iTech World 110 amp hour lithium batteries, and they've been linked in parallel to each other, giving a 12 volt bank, but at a little over 300 amp hours capacity. Like everything else in this build, it came down to the millimetre to be able to fit those batteries in there. Anybody think I did some measurements before I started the project back at the CAD stage? And there are just so many unknowns then, and I keep ever being surprised by how tight it fits. On the subject of tight fits, the inverter is mounted against the end wall here, and as you can see there's scarcely 3 millimeters gap. Again, I just got lucky, I think. Let's hope this inverter works better than they can spell. Okay, well, it's time for a smoke test. I've only twitched a couple of wires together and hooked it onto a computer power supply temporarily, but we've got lights. The other switch there turns on an external light, as does this one. Out the back, down the side, and one out the front. Just gives a general illumination for a campsite. Okay, rather than bore you with every single wire being attached and the panel laid out, etc., I thought I'd just give you a final run through at the completion of the panel. Over to this side here is the 3000 watt inverter, which you saw me putting in, and here is the small low current 12 volt distribution board that you saw me wiring a minute ago. Perhaps we ought to start with the main battery feed. Main positive from the battery, which is just through the other side of this wall, comes in here to a high current battery isolator, which then feeds the high current 12 volt bus bar. Coming in from above here is the negative leads from the battery, It runs through a shunt. The shunt's there to measure current draw, and by various wizardry can also calculate remaining battery capacity, etc. And that feeds into the main high current negative bus bar. Those two bus bars then feed with fairly large wires into the inverter. Now the inverter supplies 240 volts into this control cabinet, where we have a circuit breaker, 10 amp circuit breaker, a relay and a 240 volt timer. The relay's job is to take information from the push button on the control panel inside of the cabin. It takes a 12 volt signal from that push button, momentary signal, and provides 240 volts to this timer. This timer is a countdown timer and can be set anywhere between 1 minute and 20 minutes. I have it set at about 10 minutes, and its job is to provide power to the hot water system. As I described before, once you push that push button inside the cabinet, you'll get a signal which closes that relay, which starts that timer, allows 240 volts to run to the hot water system, and then at the end of that 10 minutes turns the hot water system on and off again. From the bus bars here, we're connected to the Renogy DC to DC battery charger. That's currently rated at 50 amps, and it has the ability to take a charge from one of two places, or both of two places, the alternator or from the solar panels on the roof. And it'll take power from either of those sources whenever one of those sources is available. So if it's sunny, it'll take power from the solar panels. If we're driving, it'll take power from the alternator and use that to recharge the battery. From the high current bus bars, I'm also running through a 50 amp circuit breaker, and that is there simply to provide power to this 50 amp outlet for the Anderson plug, and a USB plug socket rather, for just in case. This one is to run things like my air compressor for pumping tyres, etc. Then the alternator supply from the car runs through a 70 amp circuit breaker, and the solar panels from the roof run in through a 70 amp circuit breaker before they go to the battery charger. And relatively low current is supplied through to this fuse box, which has 6 fuses. The fuses have LED indicators to tell you if one is blown or missing. Then this unit here is a DC motor controller. It's there to provide power to linear actuators, which will be opening the roof. And it can operate with a remote control as well, and has a polarity switching function so that you can run those motors up or down. There's 240 volt power outlets, one for the hot water system, one for the induction cooker, one for a low current outlet in the cabin for charging laptops, and one here for running external supplies, tools, whatever I wanted to do there. Then one of the things that is run in here is a Zito battery charger that'll allow me to run my battery tools. In particular, I carry a battery impact wrench for doing wheel nuts, and an electric chainsaw, just in case I need to move a tree or chop up some firewood. So that's pretty much covers the electrical system.